Hey guys, myself Shivang this side working as a DevRel at Router Protocol, and welcome to the part 1 of building an OmniChain token on Router Chain. So in this video, in this tutorial series, we'll be basically building an OmniChain token which will be deployed to Router Chain, and as well as it will be deployed to two EVM chains that are Arbitrum and Polygon. So let's get started. For building this particular token, this project, we'll be using Router Academy, an end-to-end platform for learning about router protocols. So just go to academy.routerprotocol.com if you haven't accessed it yet. And after that, just go to Build Now. After clicking on Build Now, you will be directed to the courses section of Router Protocol, where you can easily access all the courses, all the documentations along with the video tutorials. So just click on Start Learning. After that, go to Router Chain. Then just go to building on Router Chain and then directly go to module 9, that is building an OmniChain token on Router Chain. Here's the link for this particular module. We'll be linking it down in the description box as well. So this is the entire module which we'll be using. This is basically the entire documentation which we'll be using for building this particular project. It contains everything which you need to know for this particular project. So you can just directly start by cloning this particular repository. I have already created a sample project repository for you guys, which you can just directly refer to in order to save your time. So you can just directly clone this particular repository, and here are some of the guide steps which you can use to install Git in your local machine in case you haven't. So this is the entire file folder structure. We'll be understanding it in a minute. And here is my VS Code terminal, my Cursor AI terminal basically, in which I have opened this project already. I'll quickly zoom in a bit so that it just gets better for you guys. And yeah, so I have already cloned this particular repository in my editor, and here are two directories as you can see, CosmWasm and EVM. As the name suggests, EVM directory is basically used for handling and writing all the smart contracts on the EVM side, that is for Polygon and Arbitrum, which we are building. And CosmWasm, as the name suggests, it contains all the scripts, codes and smart contracts for the Router Chain part, for the code which we are writing on Router Chain. If I just go to the file folder structure, which I'll be covering it in a minute. After that, if you go to this particular documentation part, I have added the resources for CosmWasm side and EVM side. In this particular video, in this lecture, we'll be understanding the source code of EVM side, and for the CosmWasm, we'll be understanding it in the next part. If I go back to my Cursor AI editor, I'll be opening up the EVM side of the smart contracts. Here I basically have couple of folders: contracts, deployment, tasks and utils. Contracts folder basically, as the name suggests, contains all the smart contracts which we are gonna write. Like right now we are having a smart contract called as xerc20.sol, which basically is an OmniChain token called as xerc20.sol. It is the naming convention for an OmniChain token on Router Chain. If I go to deployment folder, it basically contains all the deployment scripts, all the JSON files data which I had deployed the smart contract previously. Tasks basically contains all the scripts which are essential for deployment of the particular smart contract. Like if you see, I have xerc20.ts, I have deploy on eachchain.ts, I have index.ts, enroll on chain.ts, enroll added chain, as well as store deployments.ts. These files are really important. Basically, these are the hard hat configuration files which are important for the deployment of smart contract. Utils, as the name suggests, it basically contains some of the utility files, basically chain.ts, onchain.ts, types.ts and utils.ts, which basically stores all the essential utilities and information which will be used for building our smart contract. If I just cover the CosmWasm directory, so it contains .cargo folder, which basically contains some of the default configurations. Artifacts folder, it is the folder which we get while we build our smart contract. Contracts folder is the most important folder which contains all the smart contracts written on Router Chain. Under SRC directory, you can easily see all the smart contracts. We won't be going in depth in this video right now. We'll be covering all the smart contracts from the next part. If I close it down, packages basically contain some of the execute messages, some of the basic enums and structs which we've written, as you can see. as they are really essential for building of our smart contracts. I'll just take it a bit down. And yeah, script folder, as the name suggests, contains some of the scripts which are important for the deployment of our smart contract on router chain. And target folder is the default folder which is generated as we run the cargo build command in order to build our smart contract directory. And talking about tasks, so again it contains some of the essential tasks for deployment of our smart contracts on CosmWasm and router chain sides. So I'll close it all and I'll just go to the contract folder of EVM side and I'll open the xerc20.sol. If I go back to the courses documentation, as you can see here, I have written all the code pieces in detail. I have explained all the code pieces in detail. If you're someone who likes reading the documentations and likes enjoying basically reading stuff, so you can just directly refer it. If you need more in detail information about it, so I'll just explain it. First of all, here are some of the import statements. Pragma statement, as we all are aware of, is the basic Solidity import statement. And here are some couple of import statements. We are using a package called as router protocol EVM gateway contracts, which is basically the EVM side package for router protocol if you want to build on EVM contracts. So we are importing idap.sol from this package, as well as igateway.sol and utils.sol. These are the three files which we will be using in our project. As well as we have imported xerc20.sol from OpenZeppelin, as well as safe erc20.sol. Now, talking about the structure of this particular smart contract, we have a line called as added public owner. It basically defines the address of the owner of the smart contract. String public chain name basically defines the chain name of this particular smart contract. Like right now in this project in EVM directory, we'll be deploying our smart contract to Polygon and Arbitrum. So the chains which we'll be using will be Arbitrum and Polygon. iGateway public gateway contract basically defines the address of the gateway contract. If you have watched the Understanding Router Chain tutorial series, in that we have covered about what are gateway contracts and why they are essential if you're building on router protocol. If you haven't watched that video, just go and watch it out. So uint64 public destination gas limit, it basically defines the gas limit on destination chain while you send a cross chain request. Now, as you can see, we have created three mappings here. The first mapping is called as name. It is a string to string mapping which basically corresponds to the chain ID as well as the chain name. Another mapping which we have is also a string to string. It is called as our contract on chain. It basically is a mapping of contract addresses on the source chain as well as the destination chain. The last mapping which we have is of gateway. The name is gateway, and it is a string to address mapping which basically stores the gateway addresses corresponding to their chain name. Alright, now moving down to the constructor function. Constructor function, if you are new to Solidity, it basically is a function which runs the first time whenever your smart contract is deployed or called upon. So the parameters which we are using is chain name, the name of the chain, as well as amount of the tokens. The name of our token which we have deployed is Omni, and we have given the name as OmniChain Token. Here we are using the chain name and their IDs. Like right now we are using Arbitrum and Polygon. I have added the testnet chain IDs, as well as, if you can see this particular code, these are the gateway contract addresses of the basically MOI testnet. Alright, this is of Arbitrum. Forgotten to edit it here. This is of basically Arbitrum testnet, Arbitrum Sepolia, as well as Polygon MOI testnet. Alright, and basically we are storing these chain names here in the chain name array, in the chain name mapping which we created above. We are again using the addresses, we are using the gateway contract addresses. Here we have defined the owner, which is basically message.sender, and we have also created a mint function which is basically used for minting these tokens, right? And lastly, we have basically called a method here called as setDAP metadata. This is a function which we'll covering a bit further. It is defined in the smart contract later on, and we'll be covering it in a while. So if you want to explore the different gateway contract addresses, and you wanna use some other chain for deployment of this token, so just go directly to docs.routerprotocol.com. and just go to networks, go to supported chains, and here you will be able to see all the contract addresses. Just go to testnet, like right now we are building on testnet. Go to gateway contracts, and here you will be able to see the gateway contract addresses of all the chains router is supporting right now. There are more than 30 plus EVM and non-EVM chains at the moment. So like right now I use Arbitrum Sepolia testnet here, so you can just directly use it from here. As you can see, I have imported the contract address here. Alright, and yeah, now moving on to the set DApp metadata function, which we just used it here in the constructor function. Set DApp metadata function is basically used to set the fee pair on router chain. It is basically used to define the fee pair address of the fee pair on router chain. So what is a fee pair address and what is a fee pair? So I'll quickly show it to you. Go to testnet.routerscan.io/transactions. This is an explorer of router chain. So just go to more and fee pair. Now what is this? Basically what happens is whenever you are writing smart contracts on router chain and whenever you are deploying them, you have to give a fee pair address. Fee pair address is the address of your wallet with which you are deploying the smart contract and with which you are going to pay for this gas fee. So if you go to route scan, what happens is you have to connect your wallet. I'll quickly connect my MetaMask wallet. And yeah, now what happens is, like right now it is showing blank. It is because at this moment I'm not deploying any smart contract. If you're deploying a smart contract on router chain, so you have to give permission to router chain that using this particular address, using this particular fee pair address, you will be paying for the gas fee. So let's say this is my fee pair address, right? So I'll have to permit this address via router scan that I'll be paying fee through this address. So router explorer would be admitting it to pay the fee. And the further code of this particular function is we have user require statement, which is basically a check we've added that only the owner can do this particular thing. And then we have used the gateway contract .set DApp metadata to allow the person to basically take further the fee pair address, right? Now we have the set gateway function. Set gateway function is basically used to set the router gateway contract. It is basically used to define the gateway address of the gateway contract, right? Again, as you can see, we have added a require statement check here, and we have added the gateway contract is equals to iGateway, which we had imported from router gateway contract files. And lastly, we have a function called as function mint, which is basically, as the name suggests, it's a simple open Zeppelin function which is used for minting of your tokens on EVM side. And we have added another check require statement, and then we are adding the mint function for minting of these tokens, right? Now another function which we are having is called as set contract on chain. It contains two parameters called as chain name as well as contract address. It basically used to define the address of your contract on the chain. Like right now in the chain name we are having two chains, Arbitrum and Polygon. So it is used to define the address and the contract addresses as well as the chain name, right? Now transfer cross chain. This is the most important function of this particular file because this is the function via which we'll be making our token an OmniChain token, right? So we are using two parameters here called as amount and the destination chain. Amount, as the name suggests, is pretty simple, and destination chain is basically used to define the destination chain to which you want to mint this particular token. All right. We are adding some require statement checks here. We are using the KCAC algorithm to basically do some checks here. And some another checks which we have added that the balance of the owner, the account balance of the owner should be greater than the amount, which is a pretty obvious statement. If it isn't, then it would prompt an error to you. Burn message.sender.and amount. It basically is used for burning of the tokens from the address of the user calling this particular function. All right. Now comes the most important part of this function, this particular part, which is bytes memory packet is equals to abi.encode message.sender comma amount, the line number 106 which we are having. So what does .encode function .encode method is doing here? The .encode method is basically encoding the data which we need to send to the destination chain for the minting of tokens. What happens is On the source chain, we use a method called as encode method, and on the destination chain, we use a method called as decode. So encode basically sends the sender's address as well as the contract address in the form of a packet. As you can see, we have created a variable called packet. So it sends these details in the form of a packet to the destination chain, and the destination chain then decodes these packets and verifies the information, right? As you can see, we are requesting a packet here of the contracts on chain as well as the packet. We have created these variables, right? Then we are using an iSend function, which is a really important and a crucial function of the CrossTalk library. CrossTalk library is again used for writing all the smart contracts. The entire smart contract which we are writing right now is being written using CrossTalk library. So what is iSend function? Again, if you go to docs.routerprotocol.com, just click iSend here, just type iSend here, and you will be able to read everything about the iSend function. The iSend function is basically used to allow users to configure the different aspects of cross-chain message passing based upon the requirements. Like it contains different parameters, the version, the route amount, router CPN, destination chain ID, request metadata, as well as the request packet, which everything we have covered it here. You can see the 5-6 parameters which we are using here. We are using it from this function. All right. Now comes up the get request metadata function. All right, I'll zoom it out a bit. I guess it would be more clear to you guys. Get request metadata function is basically used to request the metadata which is to be sent while initiating the cross-chain request, right? It basically returns the request metadata and ABI encoded metadata of your source chain and destination chain. As you can see, we have used different parameters here: the destination gas limit, destination gas price, acknowledgement gas price, acknowledgement gas limit, relayer fees, acknowledgement type, and is red call, as well as ASM address. So it is a pretty simple function which has to be written. It basically defines the metadata which is initiated while you make your cross-chain request. All right. Now another function which we have is iReceive function. So what is iReceive function? iReceive function is another really important function. It basically is emitted whenever your packet, whenever the encoded data which you converted in the form of packet is received on the destination chain. At the point when it is received on the destination chain, an iReceive function is emitted. Now what it contains? It contains basically 3 parameters again: request sender, packet, as well as the source chain ID. All the information which we added in the request packet, as you can see above, it basically emits all those data, all those information in the form of a iReceive function. All right, we've added a check here, a check statement called as require statement. Basically, if the owner is not the address of the gateway contract, basically the gateway contract address is not the correct one, it would just easily give an error, which is a pretty simple check statement. Another check statement we've added of KCAC. And lastly, the thing I was talking about, the decode method, right? We'll be using it here. Decode method basically decodes the information which he had sent from the iSend function, right? It is decoded in the iReceive function. All right, we basically decode the packet, the address, and the numbers, as well as at this point we then mint the function to the destination chain. All right, as we know, the token we are building is an OmniChain token. So during this particular function, transfer cross-chain function, and before that, the code which we had written, it would have basically minted our token on the source chain. Let's say source chain is Arbitrum. So on the Arbitrum chain, it would mint our token. But if we go to iReceive function, it has to be minted to the destination chain as well. And this is being done by the decode method here. All right. Now, the last 2 functions of our smart contract. Acknowledgement function, again a really important function of CrossTalk library. It is basically used to handle the acknowledgement received from the destination chain back to the source chain. Now what happens is, as iReceive function is emitted, what iReceive function does is it basically emits an event, and it emits that we have received the packet, we have received the request packet, and it basically does the decoding aspect. Now acknowledgement function is a function which emits an acknowledgement that the packet has been received, and this goes back directly to the source chain. All right, it contains 3 parameters: request identifier, x flag, and exe data. All right. Now, what is request identifier? Request identifier basically is an event nonce which is received when we create a cross-chain request. You can easily keep it in the form of a mapping of nonces which have been executed and which haven't, right? X flag, execute flag is basically a Boolean value which suggests whether the call was successfully executed on the destination chain or not. Lastly, we have execute data. It basically returns the data in the form of function call from the handle request from source method of the destination chain function, right? And last but not the least, we have a function called as toAddress. It basically converts the type address into type bytes, right? And again, we have the parameter called as bytes here, which is pertaining to the address, as well as we are using the source token address here. And a pretty simple, we are using the assembly code here. And yeah, that's like pretty much about the XERC20 Sol token, an OmniChain token which we are right now building on the EVM side on Arbitrum and Polygon chains, as we talked about it, right? The router chain part, the token to be deployed and written on router chain, we'll be covering it in the further parts. As well as if you see the deployment configs, here are like xerc20.json. This is not something which you will be writing. It is something which I had received when I deployed the smart contract of this, and I had received this JSON format data. All right, and yeah, like that's pretty much about this particular part. I hope the EVM side of this particular smart contract was clear to you, and let's meet in the next video. Thank you.